Let's use this one. And I'll take this one. Do you have my number?
No, but I don't have actually your number, so maybe you can give it to me. It's fine. Thank you.
So they have to go on this link if they want to. For all of those.
Or maybe do you want to introduce this?
Yeah, maybe you introduce.
Okay.
So I think we will start now. So we will start the workshop. We have a pretty tight schedule. Before we start, I show you the schedule. Mathieu just want to explain about the presentation, what we are going to use today.
Yeah, it's very quick. You just have to copy this link on your devices, either your phone or laptop or tablet, and when you will click on this link, there will be you will already see this window here, and when I will launch the presentation, you will see already the shared presentation, and it will ask you to log in with Facebook or Google, but you can skip that. There is also the skip button, and yeah, that's all basically. So.
And to go to the presentation, you have to change from one to the other?
No, it's everything you can be managed here. So yeah, so the speaker will just go on with the presentation. So if
is that you just press here?
No, I will launch it, but I have to wait that everybody is connected, maybe because maybe also from the web streaming. No, what? They're not connected. Okay.
Is the web streaming working?
You cannot see it? It's okay. I can try to launch it. So. So you can try to see if you can zoom on. Okay, and then you just go on with this.
Yeah. Okay. So the workshop here is a combined workshop for two Horizon 2020 projects, hybridGEOTABS and ALDREN, and you will hear more about what that means. We will have in between a small break, coffee tea break, but only about 15 minutes, and we will close about 4:30. The first part will be dealing with the ALDREN procedure, where we have several presentations. We will, when we come to the at the end here, to the question and discussion, we will have some questions which you will have to answer on online, and then we will look at the answers for how many people answered on the different answers. And after that, we will go to the hybridGEOTABS. Basically, the same at the end. We can have questions, discussions to GeoTabs, and we are again using this presentation where we have uploaded some questions. And then we have a half an hour at the end if we follow the program for having a general discussion. Now, each of you, I think all of you, have like 10 minutes presentation. So, and we need to keep the time schedule, because else at the end it will be after midnight here. And some of us have a reservation at a restaurant we have to go to. So let's start with the first presentation, the introduction to ALDREN, and Johan.
It's Mathieu.
Oh, it's Mathieu. Yeah. So I was not sure about the names here, but I hope the one who presents is here. And you just go to the next by pressing the arrow down.
Perfect.
And please, you cannot turn around and you want to point. Use the mouse as pointer, because then you will be pointing on all three screens at the same time, and you can still look who is sleeping.
Exactly. Just see one last thing. Sorry. Just one last thing. On the bottom right of the presentation, you can see that there is a little cloud. So if somebody wants to ask a question during the presentation, just type the question, and then we will read the question after the session.
Yes, thank you very much, gentlemen. Thank you for your experience, Jana, helping to find the right positioning. Do you still have it on screen? Yeah. Obviously, yeah, I'm not Johan Zangibou. Yeah. Can you just come back, Mathieu?
Of course.
I don't know.
So signal is not that nice. Okay. This is rather a technical problem than a presentation one. So you can see the presentation on your computer. Okay, so we can stick to it, and meanwhile I'm calling the tech guy.
Please, Pepper, tell me if we experience any problem. Yeah. So my name is Mathieu, I'm working for CSTB, and I will be presenting very briefly ALDREN on behalf of Johan Zangibou, who was supposed also to present today but tired after the morning session, and Olivier contributing as well to the coordination. ALDREN, as most of you already know, is about an alliance for deep renovation of buildings. And we are definitely focused on non-residential buildings, hotels, and offices. ALDREN is developing at the moment through an H2020 project, which is a CSA, coordination and support action. And this is quite important, because we do not intend to develop very new research and very innovative methodologies. Our purpose is much more to consolidate the existing ones, to intertwine and make connections in between, and to promote and disseminate. We are 8 partners contributing to that project. 3 of us are more linked with the research institutions and research sectors, namely CSTB, DTU, and Polemy. We associated to the project, and we think it's very important, 2 certification bodies, Certivea and IVE, because we want the methodologies that are developed to be consistent and operational. And then there are also private partners and professional associations contributing to the development of methodologies and disseminating the contents. Why did we decide to launch that ALDREN project? With ALDREN, we face and we try to tackle different challenges. The first one is that we need more comparability, more transparency, more quality, especially on energy performance assessment and certificates, but more generally on the certification of deep renovation programs. And this is why we need to create a European quality benchmark based on EU shared standards. Then second challenge, second approach would be the policy support. We also have to give, in line with the revision of the directive for energy performance of existing buildings. This directive also, let's say that revision, introduced different topics. Reinforce the building stock observatory, enforce cost-effective approaches, introduce a building passport, evidence-based on expected energy savings, wider benefits. And we have also to give support to member states and give support to stakeholders on applying this directive. And then nobody can trigger deep renovation alone. And this is the reason why we need to create an alliance associating various stakeholders on the deep renovation sector and work out with them a kind of common language, meaning that, yeah, financial institutions should be able to communicate and to work with building designers, how a thermal bridge could talk to a banker, so that we all assess deep renovation program on the same basis and language. We think, for that slide, we think that an overall and holistic approach is crucial to promote deep renovation. We think it's crucial because, yeah, it will convey and it will help to develop the overall quality of renovation. This is not just a matter of energy performance or predicted energy performance. This is a matter of meeting our targets. This is a matter of improving health and comfort. This is a matter of underlying and allowing building valuation to increase and to consider these additional benefits. And this is the reason why you have these 4 tasks in parallel developing in the project. Then we have a kind of cross-supporting action with the collection, the structuring of the data through a building passport. And on top of that, yeah, we work out this common language and consistent integration of the different methodological pieces. We intend, as I said, to support the revision and the development of policies and energy performance policies. And we would like to highlight that the ALDREN outcomes are related actually to 17 paragraphs of the EPBD amendments. So we are definitely focusing and trying to contribute on that topic. I would like to stress again that we are not supposed to deliver additional, very innovative or breakthrough research. What we intend to make is consolidate the existing methodologies, the existing research, thank you, and articulate them, disseminate them, and use as much as possible existing know-how. And this is the orientation that our task leader tried to follow. I will be very quick on the following slides because my colleagues and different type of task leaders are going to give much more details. But working on energy rating, we obviously try to tackle the challenges of comparability of results at EU scale and transparency. Then Robert Cohen for Verco will give a talk also on how we assess the gap in between predicted energy performance and actual so that we meet targets and restore confidence in what has been already promised and through the use of supporting tools. I guess Pavel from DTU will explain to you also how we consider the benefits in terms of health and well-being in the context of ALDREN and how we propose to assess them through a set of indicators and gather them according to some quality mark. We would like at this stage to recall that our focus, our scope is on the actions on buildings that have linked with the increase in term or improvement in terms of energy performance. So our scope is improving energy performance. Still, we have direct benefits on energy and obviously as well on non-energy health and comfort. And just to give an example, maybe in the sector of hotels, energy renovation may help to avoid overheating and then improve in the offices the productivity and improve maybe in other sectors the sleep quality. We definitely have and work out the interactions in between tasks. I did not mention it earlier, but all methodological pieces, all protocols are supposed to be standalone because we want to make them accessible for already existing voluntary certification scheme, but they also interact, and they can be presented in a consistent overall approach. And in this interaction, this is just an illustration to see that when we obviously perform deep renovation, we improve energy performance. We may improve the air or modify air and operative temperature. This has an impact, obviously, on thermal comfort, linked with productivity, and linked in the end with building valuation. And these links are also at the heart of the ALDREN projects. We are getting closer to the conclusion, and I see time is running. As we said, there are different ways in which we would like to use and exploit the ALDREN outcomes. One way is to introduce them into certification scheme, either in a consistent scheme or as standalone pieces in the existing ones. And two partners are supporting the HQE and IVE certification scheme. We have close contacts with BREEAM and the ENBEE, interested at least in some pieces of the ALDREN approach. We can promote, and we would like to promote also, having contacts in Slovakia, having contacts in France, and I'm sure this will not be the end, with member states, so that member states and public authorities can also use the ALDREN outcomes to influence the development of IPCs. And ALDREN raises opportunities for a set of various stakeholders, building owners, investors, developers, getting kind of gain and performance quality recognition through such certification scheme. Financial sector, which is able to develop financial instruments or to orientate financial credit lines in terms of using European tools, allowing benchmarking and assessing on transparent and comparable baselines. Benefits for building professionals, harmonized procedures, harmonized database, coherent and transparent level playing field, and obviously potential benefits for countries and for member states, saving money for the EU as well, trying to work out common approaches. I thank you greatly for your attention. Yes, this was just an introduction. We will be very happy to collect your questions, so please use the presenting interface to collect and write your question. We will address them at the second time. In the end, I guess we will have a quite short polling session to get also your impressions and feelings on different topics. Thank you very much.
So, good afternoon, ladies and gentlemen. So, I will briefly inform you about the content of task 2.2, that is development of European voluntary certification scheme and rating of energy performance. So, the main features that should attract market, we think, are the harmonized calculation methodology based on 10 standards that were this standard developed under mandate 480. Then this common energy performance rating will provide the comparability of energy performance and transparency across Europe to support the European level of building stock management. Then harmonized consideration of innovative solutions will give the same evaluation to all of them. European voluntary certificate aims to be advisory tool for building owners, tenants, managers, because it can be issued before and after renovation. And as was said before, the voluntary certificate can stand alone as certificate, but also can be included in existing voluntary certification schemes. So the main technical pillars for harmonized comparability European-wide are calculation methodology, then indicators, performance scale and reference on this scale, and content and template of this voluntary certificate. So regarding calculation methodology, it will be based on CEN standards, which is methodology also referenced in EPBD Annex 1. The software used and also methodology included in software will be allowed if it is close to CEN standards, but it must be based on hourly calculation step at least. The typical use based on national standard use and climate of the specific location of building will lead to the closer result to the actual energy performance, because at national level in obligatory national certificates often the standard climate is used for whole country. And then there is discussion about primary energy factors that will be used. Advantage of this common methodology is that there will be a level playing field for all technical systems for innovative solutions, but it will also support the common market for software companies, but also for training of experts, because then experts at international level can make this energy certificate in different countries. Here I would like to refer also to other project which is connected with ALDREN, and it is its CENSE project about training of use of this calculation methodology based on CEN standards. So in EPBD about indicators, EPBD says that the energy performance of buildings shall be expressed by a numeric indicator of primary energy in kilowatt hours per square meter, but there is not specified which type of primary energy and what will be balanced with produced energy. So you can see on the graph different results for the same building using different indicators, which all are in line with EPBD. So this is the reality in national certificates, that you can have different results. So in common voluntary certificates, there will be clear and harmonized common indicators of energy performance. There will be two main indicators which will have the energy class, and it is non-renewable primary energy balance. It means that export of produced energy is allowed, and then it will be non-renewable primary energy, where is only auto-consumption of building taken into account. There will be also other additional indicators which are, for example, needed by existing certification schemes, because we discuss with them what they need as a result from energy performance calculation. And there will be common template with prescribed pages of this voluntary certificate, where will be one page also about recommendations for improvement, and this page will be connected with building renovation passport, that is other task of this project. So very challenging is to set the common scale for Europe. So it will be based on relative scale with one reference point. This is also option in new CEN standards. And we have to define this reference point, which we propose it is cost optimal level in 2013. And this cost optimal level was very clearly reported by member states to Commission, and the results are available. But today member states have more strict requirements. It is about class B or C. And there will be class A, which will be approximation to national nearly zero building definition, but it will be ALDREN nearly zero energy building in class A. So in project we test the more options for this scale. So one option is that it will be differentiated by climates. We propose to refer to the Commission recommendation for nearly zero energy building, or it can be fixed value for all climates. That was proposed by Commission in 2016. So in the project we test these options on model buildings for 3 climates, for 3 levels of building quality. So this will be tested on model buildings, but also finally on real pilot buildings. Regarding the scale, we also test the step-by-step renovation to be visible on this scale. The steps of renovation, if they will improve the energy class. So here there is a clear link with recommendations for building passport, and the result about cost savings for energy will be reported in task 2.5 about financial valuation. So regarding the performance of building in different climates, so it seems now that differentiation between 3 climates at least will be needed, because you can see on this picture that for existing buildings there is a dependency on building stock quality. So you can see that in Bratislava climate there are worse buildings than in Helsinki. In this climate it is more cold, but in cost optimal level, it is the second group. You can see that there is dependency on climate, but for nearly zero energy buildings, they seem climate neutral, and solar gains and potential for PV electricity production are the main drivers for difference between near zero energy buildings. So results from energy performance rating calculation will be input in other tasks, so there can be comparison with measured real performance. Then it will be input in health and well-being evaluation, because we have hourly data about indoor temperature, humidity, and other parameters. Then there will be input to financial valuation, which is energy cost savings, and all data will be collected and reported to owner in building renovation passport. So thank you for your attention.
Thank you. So we will go to the next energy performance verification.
Good afternoon, everyone. So what do we mean by verification? There's 2 things that we're trying to do here. One is to ensure that a real building has the ability to measure how much energy it is using. So you have the meters in the right place and can compare how much energy the real building is using for different parts of the energy supply, so for heating, cooling, fans, pumps, and so on, lighting, and compare the actual energy with the predicted energy on a like-for-like basis. The second thing we're trying to do with verification is to demonstrate that the predicted performance is reliable and robust. And in order for the real building to perform like the predicted building, the real building has to be really efficient. If it is really efficient, it will perform like the predictions. If it is not efficient, we will have the performance gap, a very famous performance gap. So we have developed 2 tools to support the verification process. The first tool is a protocol which identifies the activities that need to be done in order for your building to turn out efficient. And the second tool is what we call a verification tool, and this is used to collect data from the building model and data from the building meters and create a framework where those 2 can be compared like for like with each other, so the predictions compared with the measurements. So if we look at the process for a deep renovation, which is the purpose of the ALDREN project, we have identified 5 phases. The first phase is we are calling decision, and that is where you set the level of renovation, or how much energy improvement you will be targeting. The second is to develop the design. The third is to do the detailed design. The fourth is to implement the renovation, and which we call works. It's the construction activity. And then lastly, we have the performance of the real building when it is in operation and in use. Now, if you consider the conventional way of assessing the performance of a building, you should look at the left-hand column here, and in that you will see we calculate the performance of the building according to a theoretical model. And initially you might have a calculation before renovation. You will then, during the design, do a new calculation to demonstrate how much improvement there is, in theory. And then at the end of the construction, when the building is handed over to the occupants to use, there may well be a third calculation in case the real construction has been slightly different from the original design. So these are a very nice, easy set of indicators for the theoretical performance of the building, and that is the indicator that is currently used throughout Europe to decide the energy efficiency of a building, and is generally on an A to G scale. The performance gap arises because real buildings do not have the same performance as is predicted in theory. So for the verification process, we are introducing two steps to identify the difference between real buildings and modelled buildings. So before renovation, we have a process of modelling the building under real conditions and comparing the results with the measurement of the building obtained using an audit. So we are not sure how much information we will get from an existing building, because often there's very little metering in the building, but we will use as much metering as there is to calibrate the model so that the predictions of the model for heating, cooling, fans, pumps, and so on are as near as we can get equal to the measured use of the building. And the reason for doing this calibration is to identify a more appropriate refurbishment plan. Because if we know that the building is actually using more energy for heating, it might be cost effective to apply stronger measures to reduce the heating. Whereas the model might say that in theory this building is using very little energy for heating. All the energy is coming from the occupants, all the equipment inside. So that is a calibration process we use at the start of the refurbishment process. And at the end of the refurbishment process, once the building is in operation, we repeat that in the sense that we measure the performance of the building with meters and compare the measurements with a calibrated model of the building. So the model, instead of being run under standard conditions, is run under the actual conditions that the building experienced when it was being measured. So we have a like-for-like comparison. So this protocol identifies each of the activities that are needed at the different steps of the refurbishment process. So we have initial requirements at the start when the decision has been made, what to do, what commitment to make in terms of performance. As the design is developed, we have additional steps which include very detailed modelling, much more detailed modelling than is used for a performance certificate. And once the building starts to be constructed, we have to make sure that the actual building is following the design. And that will inevitably mean a lot of fine-tuning of the building so that the control is as intended. And then when the building is in use, we need to measure its performance and collect the data to enable the verification to be done. And then the second tool that we have is this data collection verification tool, so that at each stage of the process we have a framework to collect the information from the building or from the model, put it into a standard framework and enable a comparison to be made. So for example, we calculate the performance gap for the existing building between the calculated and measured performance, and we calculate the performance gap for the completed building between the calculated and the measured performance. And just to give you an illustration of what the final output might look like, this shows you the difference between the predicted and measured energy use for different end uses of energy: heating, cooling, cooking, fans, pumps, lighting, small power, for each month of the year. And this is actually data for a real building that we have applied the process to. You can see that the color coding indicates how close the measurements are to the predictions. The redder the cell, the worse the predictions are. And generally speaking, at a headline level, the green cells are reasonable, the yellow cells are not reasonable, and the red cells are awful. And there's clearly something wrong. Either the model is wrong, or the building is out of control for that particular. So if the pumps are operating 24/7, for example, you can see here the pumps are using far too much energy. So
1 minute.
The consequence of this is that we will produce a verified rating for the buildings going through the ALDREN process. And I think this is a really significant development for this common European certificate. It will give it a credibility in the market, which the existing energy certificates don't have. And on that, I will complete my talk. Thank you.
Thank you. So the next talk is about addressing health and well-being.
Thank you, Bjarne. Thank you very much. All right, so as you heard from the first presentation, ALDREN is about the energy renovation, but of course ALDREN is about creating incentives for deep energy renovation and also capturing the potential gains from the process. So one of the potential gain is actually aspects of the cost of running the building. So just let's look at this slide that presents the distribution of the cost of running a building, in which you have different types of dots of different colors, and energy dot is one color. Most of the dots are orange, as I see it, and these are the costs that are related to the occupants. So basically, ALDREN tries to tap on that cost in the process of deep energy renovation, because it's a significant part of running of the building. And energy renovation can actually lead to the improvement of, to that gain that is related to the occupants in a building. So this is the framework of integration of indoor air quality, comfort and health in the scope of energy renovation, is that energy renovation actions affect certain parameters that define indoor environmental quality. They can affect both ways, so they can affect both positively and negatively. And of course, it is expected that they generally improve those conditions. And modifying those conditions or improving those conditions results in an improved health and well-being of the occupants, and also the work performance, as well as sleep quality, and then that leads to the economic benefits. So ALDREN is trying to capture both the how to measure that effect of deep energy renovation and also how to quantify it in economic as economic value. I will be speaking about measuring, and the economic value will be the next step. So how we address health and well-being in ALDREN. So energy renovation, as I said, affects indoor environmental quality parameters, and we are not actively so we are not acting on improving indoor environmental quality. What we are doing is we passively observe the changes that energy renovation process bring into the building. And then we want to quantify them and then classify the resulting product, which is the indoor environmental quality in a building that has undergone the energy renovation process. Both the improved parameters and also classification of a building or indoor environmental quality in a building can result in economic benefit. So you may say this is nothing new and it has been done before in many processes, but we try to put it in a certain framework and one protocol. But of course there are certain limiting criteria for that. So we cannot select all the parameters in the world that exist, and we can of course develop a huge framework for measuring of those parameters, but it has to be doable and manageable. So the only parameters that are included in the process and are suggested in the ALDREN procedures are the parameters that are changed due to the process of deep energy renovation. So a simple example can be deep energy renovation will not change, for example, building materials, or to some extent some building materials will be changed. We know that they affect indoor air quality, so I mean we cannot act on it in the deep energy renovation process. This is one simple example. Then we need to have parameters that have been shown to affect productivity, because we want to quantify the benefits, right? So we need to capture those for which we have some evidence that they are related to those aspects. Then we need to have parameters that are measurable or can be modeled. So we need to have, so modeled is one aspect, and measurement. So it cannot be sophisticated measurement, it has to be measurement that can be managed. And then I don't know why the entire page is not displayed here on the screen. But there are two other aspects. There have to be parameters that are proposed and already included in the standards and certification schemes. So idea here is, well, we are not going to propose something new because no one will be accepting it. So so those parameters are used in other contexts, so that can be basically quickly, the procedures that we propose can be quickly adopted. And finally, we are not measuring health and well-being and such. So we do not ask people about their symptoms, about their perceptions, and we are not monitoring this at this time. So we are only making physical measurements. So just to give you two examples. So in order to select the parameters, we looked through two major aspects. The first aspect was to look at the parameters that are impacted by energy renovation. So we referred to the documents that exist, which actually try to identify which of the parameters are affected by energy renovation. And these are bolded here. I will not read all of them. But in the energy renovation process, there is plenty of parameters that are not that do not affect processes that do not affect indoor environmental quality. For example, use of renewable energy sources, heat pumps, or more effective boilers will not affect indoor environmental quality. So we try to see what of the actions will change indoor environmental quality. And then also we summarized information in the existing certification schemes in Europe and some international certification schemes like LEED and WELL, and see what parameters are used there to to determine the level of indoor environmental quality. And we just submitted a paper that is summarizing this information. So having that background, we decided to select the following parameters. And we decided that there will be both. Some of them will be measured and some will be modeled. For the air quality, there are parameters, traditional parameters such as CO2 levels, carbon dioxide level, and ventilation rate, which can be measured and modeled. There is a modeling X missing there. But also parameters that are normally related to health aspects and very seldom actually measured in buildings. So, such as formaldehyde, benzene level, PM2.5, radon, visible mold, but also the aspects of surface relative humidity, and relative humidity is considered in here. For the aspects related to the thermal, acoustic, and visual environment, in our protocols we propose to have classical parameters here, as I would say, indoor air temperature, relative humidity, but also from them estimate the indicators, PMV and PPD, for acoustic environment noise level, and for visual environment daylight factor and illuminance level. So you see, these are very, very simple, but still the simplicity does not mean that, you know, it is a step forward and advancing our, and allowing us to classify the buildings with respect to indoor environmental quality. For each parameters, we develop very detailed procedures and protocols. And this is described here for carbon dioxide. So we have a protocol which says which parameter is to measure, where it is specified, in which certification schemes it is required during the process of certification of indoor environmental quality, how it should be assessed, so either through modeling or through measurements. And if it is through measurements, we provide details, how it should be measured, in which point, how to select spaces in a building, and so on. So very, very detailed protocol, just in order to standardize and allow comparability afterwards. And then, finally, we define the criteria for ranking. And most of those criteria are referring to the existing standard that are supporting the EPBD, the Energy Performance Directive. And this is standard 16798, for those for which they are listed there. So based on the measurements and modeling, we propose classification of indoor environmental quality as a result of energy renovation. Once again, it is a passive observation. We are not acting on indoor environmental quality. And we propose the TAIL score. And TAIL stands for temperature, acoustic A, I, indoor air quality, and L, light. And these are squares that are put together to represent each of the aspects of indoor environmental quality. Well, the only aspect that we do not address here is the human occupant behavior, but maybe in the future there will be. So anyway, and then there are different colors that will tell you whether your building is meeting performance criteria for the different, parameters that define indoor environmental quality. And based on this, so you will see how it performs under different aspects. But based on this, each building will also receive the category. Here, in this case, is a category 3, is a circle inside. And it is a category that is the same as defined by the standard 16798 of the category of the building. Well, that's all. Thank you.
Thank you. And the next presentation will be on financial performance.
Hello. One of the key success to foster deep innovation will be to convince the ones that are taking the decisions, that is, that the financial market players. And to do that, we need to address them in their own language. That is, we need to translate all the information that you've seen previously into financial information that will help integrate those information, energy, health, and well-being indicators, into information that they can readily use in their investment decision-making process. To quote the recommendation from the EU High-Level Expert Group on Sustainable Finance, energy efficiency investments affect the value of a building beyond the mere energy savings. And we need to provide guidance to financial institutions on the identification and measurement of these multiple value streams going beyond energy savings that will help de-risking energy efficiency renovation. So in what do these multiple value streams consist? They consist in benefits. Benefits for the different market players that are the occupiers, who will result in, of course, decreased expenses in their energy charge expenses, but also in improved comfort and well-being, resulting in higher value in use and productivity gains if we are talking about office buildings, for example. The other benefits are for local authorities or even us at large in terms of all the public costs that will be, and social costs and social health costs that will be mitigated by the action that we'll implement. But if we go back to our main focus, the owners will directly benefit from all these actions, directly in terms of the expenses that he pays himself, as well as the indirect benefits from the other market players, such as increasing rental value, for example, due to the preferences from the occupiers. So we will focus on these owners and try to highlight how the different performance that are mentioned in the previous tasks will help and will allow to the building for have a higher value. So in this task, we have proposed different economic and financial indicators, indicators in terms of costs, energy cost and revenue, maintenance cost, the other running cost in the building, of course the replacement cost when the component has arrived at the end of its lifespan, and also the carbon cost linked to the GHG mitigations. And all these indicators can also be aggregated into what is called a global cost, calculated on the life cycle cost of all these separate cost streams. Another type of indicators that we are proposing is an indicator based looking at financial value directly. And to do that, we need to focus on different market value drivers. First market value driver is the rental value that can be impacted by the comfort, health, and well-being. It's also the rental growth. The benefits of energy, health, and well-being upgrades will also translate into lower risks and lower obsolescence for the building that will be renovated. So we also need to look at the discount rate and how it will be impacted by the renovation. Vacancy, occupation are of course other criteria that should be considered. And all these criteria will help to calculate a worth and market value or investment worth, reflecting the impact of these multiple benefits that the owner will gain from upgrading its building. Last category that we've highlighted is to specifically present how energy, health, and well-being will impact on the appreciation of the risks. So to do that, we've also proposed a protocol in the different stage. Initially, before the decision is taken, there is an initial appraisal, where the focus is to try and gather all the information collected, and in particular to use the assessment made on energy performance, health, and well-being to better inform and inform more transparently the costs, but also the information on lease rents, occupancy, to value the building. And to do that, we rest our methodology on a discounted cash flow, which is a manner to calculate the investment worth and market value in as transparently as possible. And to highlight the importance of this information and information on performance and the quality of the information on performance, it is suggested that when there is no assumptions, then worst-case scenarios be used to reflect the uncertainty and the impact of uncertainty on the financial value. For the renovation decision itself, as I said, the underlying principle is to focus on value and worth rather than just energy savings. So the idea is that for each of the energy packages that will be proposed in the other tasks, to have a care on the optimum calendar on which to make the renovation to ensure maximum impact on value. And there is two main criteria that we have considered: the life cycle of components and the optimal date for component replacement, and of course the lease term and renovation lease opportunity. If we're making and suggesting a renovation package, then to make sure that we get the higher value out of this renovation, then it must be consistent when the time where the components are out of life and when there will be an opportunity perhaps to increase the rent. So there is two main criteria that could be considered for this renovation decision. Of course, we are keeping the ratio of energy savings to investment costs, but we are adding to this ratio another one which translates this multiple value stream in the form of the ratio investment worth gain to investment costs. Just to provide an example, in the case where we've got a small renovation, let's say, we've got the owner, the financial value, will benefit from a little bit of the operation savings, in particular those that he benefit itself, that are recoverable from tenants, and but that is all. If we are targeting with deeper renovation, and if we are trying to schedule this deeper renovation with opportunity in terms of lease calendar, then it may be the opportunity to not only benefit from the operation savings, but also to benefit from higher potential in terms of rental value. And that may be what we need to trigger deeper renovation. So thank you. This was really in order to translate all the wonderful work done on the other task in terms of building a business case, a financial business case for market financial value. Thank you.
And the last presentation will be about the building renovation passport, the renovation strategy.
Thank you, Bjorn. So let's conclude the overview on the ALDREN project with the presentation of the building passport. We go straight because we are in late. And I will give you an overview replying to some general questions. First of all, why building renovation passport? Two are the main reasons. First of all, the compliancy. The recast introduced an optional building renovation passport compliancy with the APC, and ALDREN would become a current element in a common EU solution. And the second one is the harmonization. It's the right moment to avoid this and to provide a standardized passport. One main important thing to underline, ALDREN is developing a passport for non-residential building, and in particular, we are focusing within the project on office and hotel. Two are the main elements that compose the passport: the building logbook, that we're gonna to call ALDREN Build Log, and the renovation roadmap, the ALDREN Renomap. These two elements are strictly correlated, and mainly the first one is a repository of all the documentation data collected and presented by my previous colleague, and the renovation roadmap. Let's see in detail which are the modules that compose both of these elements. In particular, the build log will be composed by 6 modules, 2 more, let's say, general to set out the picture of the building, that are the building picture and the documentation on BIM. And the other 4, these are more focused on the specific topic that the presentation before me go more in deep: energy rating and target, energy verification, comfort and well-being, cost value and risk. So many topics, so many indicators for each of them. So how to organize them? We propose to have a data model organized in, let's say, 4 levels, starting from the level 0 to the level 3, in order to facilitate a data flow and a process and data comprehension according to the user that is gonna to use and need this build log. And how to do that? To organize these 4 levels in 2 parts, a back end and a front end. Because, as I said, we need to limitate even the access of data, and according to the user, they can comprehend or not this data in. And this structure that we go in deep to underline and define mainly give us the challenge to propose a centralized storage location, because right now we have so many data that are scattered over many databases or departments. And secondly, even to define data points, so standardized indicators, and even to increase, let's say, we hope to be able to reach even a consistent quality of the data. And also, concluding that part, is the reporting and the accessibility. We would like to reach a more friendly tool. What about the Renomap? It's composed by 2 modules: the elementary renovation action and the ENBEE roadmap. Here you can see that these 2 modules belong to 2, let's say, steps: the groundwork and the design. So if we check to the groundwork, there will be an audit phase and then an ENBEE compliant target, because we start interviewing building owner or energy manager, and in parallel with on-site inspection, because we need to identify which are the desired or the expected results that this owner or manager needs for their own building. These help us to set up a list of elementary renovation action that could be applied, and then these will give us to reach the definition on this renovation roadmap that could give short-term renovation packages, clustering the areas, and a timeline for longer term. So let's conclude with a quick application of the approach that we presented. Let's start with a general non-residential building that today we have in our building stock. Let's start with the data collection and then populate the ALDREN Build Log. Then will be a data flow into the Renomap. Here we are, the first release of the passport, but let's start to apply the elementary renovation action. Maybe it could be 1 or 2 according to the decision even of the owner. But that means that after that, from red became greener our building. So means that the data needs to be updated because it's improved our building. Following, even the Renomap can change and could be readapted, and even the dedicated timeline. So a new release of the passport. This it's important for us because we don't want that the passport will become another static elements or documentation. So to be continued, the target is the ENBEE, and it's according to us, that's where we would like to reach for our existing building. Thank you.
Okay, can everybody see also on their devices the poll?
Yes.
Okay, so we'll start with the warm-up questions, 4 warm-up questions, and then we will just go through the ALDREN question, and then I will show also one question that we had during the presentations. So the first, I will just read the question, and then you will read the answer and check them, because otherwise it will take too much time. So the first question is, to which of this group of stakeholders would you affiliate your organization or yourself? So you can already start to vote it, and I think, I don't know, maybe we are, Liz, how many we are now, do you know? Because I can see from the total votes when we will be over with the votes. Liz, do you know how many we are now, like 30, 40, 39? Okay, so when we will reach 30, maybe, or maybe less, we can go ahead.
So hurry up.
Just 13, okay.
Only certain people know who they are.
Maybe because not everybody is connected. Why you are not connected?
So people didn't know that.
Yeah. Do you have your mobile phones? Because you still can join. Okay. Sorry. Now I'm doing. Okay. Maybe we can still one. Okay, I can show just the result here. So we have 50%. It's on research and academia. Okay, the most. Okay, so we can go to the next one. So the second one is, how familiar are you with voluntary certification schemes? So you can start. In the previous one, we were like 14 or 15, so maybe this is the total amount of people voting. Is how familiar are you with voluntary certification schemes? You can already start.
Probably, what is the voluntary? Yeah. What is the scheme? What is the benefit?
So yeah, maybe people are not answering because it's not so clear, the question. Yeah. Okay, but still, I can show the result now. We are 18, so yeah. So we can go to the next one. So how familiar are you with the set of EPB standard generation, the first generation, 2007? Oh, they're increasing now. People get more confident, maybe. Okay, 22, I think it's enough. So, okay, this is almost shared enough among the 4 replies. So, the next one is, how familiar are you with the set of EPB standards of the second generation, 2017? What? Okay, 21, I think it's enough. Oh, okay, so this is more, and you are not all familiar.
So people are less familiar
with the second generation.
Normal. Because it is younger, but it's more recent.
So, okay, after the warm-up questions, we can just skip to the first question on ALDREN. So, do you believe that European voluntary certification schemes is interesting for your current activities? Yeah, that's a good suggestion.
You can still participate in something you don't believe in.
Okay, 17, 18, maybe we can just go up to 20 and maybe not. Okay, I can show it. So it's yes, under some conditions, the main reply to it. So let's skip to the next one. What do you believe would be the main market drivers for the European voluntary certification scheme? Then start. Oh, not a lot of replies here. Okay, I think 21 is enough, so I can show it. Oh, okay, there are a lot of different, still people. Because I think this one was a multiple answer. Is it right? You could choose more than one, I think. Okay, interesting. So let's get to the next one, the third one. What do you believe would be a good approach in terms of the relation between the European voluntary certification scheme and the national mandatory energy performance certificates? I'm sorry, here I had to cut the question because the presenter does not allow to add lots of characters. I can repeat the question if you need. What do you believe would be a good approach in terms of the relation between the European voluntary certification scheme and the national mandatory energy performance certificates? Okay, 20 is enough. Oh. Interesting, so it's kind of a tie. Okay, we can skip to the next one. So, do you believe it would be useful for the market if the existing wider environmental schemes such as HQE, BREEAM, DG, ENBEE, EVCS use same ISO EPB standards for energy calculation? Is it clear, the question? How much time do we have still? How much time still left? 10, 15, 5 minutes? I think we have okay. So we have to go a bit faster, sorry. So these are the results. Yes, under some condition is the main reply. Okay, let's skip to the next one. Would you be in favor of integrating the European voluntary certification scheme within existing mandatory or voluntary schemes? Okay, 20. I can just take 20 as the... Okay, yes, the European market will be benefit from our harmonized solution business status. Okay, that's pretty clear. We can skip to the next one. So do you believe the scale based on one reference point, for example, reference value in kilowatt hour on square meters per year, I think, yeah, is understandable and acceptable? $19, $19, can wait for the last one. 20, come on. Okay. So, okay, yes, under some condition is the one with more loss. Okay, we can skip to the next one. So, what do you believe is the most important indicator for the energy performance of buildings? This is interesting. More. The last one, we can wait to the 20th. Okay, the last person is always the most uncertain. Okay, this is pretty much shared supplies. We can skip to the next one. So, do you believe the list of indoor environmental quality parameters is appropriate for the market? Okay. Okay, this is pretty much shared as well. We can skip to the next one. Oh, still people voting? Okay. So the 9th. So, what do you believe is missing from the list of indoor environmental quality parameters? Okay, a lot of questions here. Okay, I can show it. Okay.
But this question is not good because thermal, indoor air quality, acoustic lighting is part of the economy. The economy includes those. It's not only how you work and how you stay.
Can go on. Somebody wants to reply? Okay, so which financial benefits should be quantified first? Market value, productivity, both are important. They should be quantified in parallel or uncertain. Okay, we can wait to the last one. Come on, no 20 people, okay. Okay. Oh, here it comes. Okay. Can I go further? Do you want to add something? Okay, let's go further. Okay, so which financial benefit is more reliable slash acceptable? Financial benefits resulting from increased market value, rent, etc. Financial benefits resulting from improved work performance, or neither of them? Okay, we reached 20, very fast. So it's pretty clear. Okay. Okay, do you believe the market shall accept that the energy renovation process must be supplemented with indoor environmental quality measurements? Yes, no, or uncertain? I'm sorry I had to cut the question. I can read it again. Do you believe the market shall accept that the energy renovation process must be supplemented with indoor environmental quality measurements? Okay, 20, I can show the result. So this is also pretty clear. Just the few more left and we are done. So what do you believe is an acceptable cost of indoor environmental quality measurements in connection with energy renovation? Less than 1% of total energy renovation costs, less than 10%, or it's irrelevant? Okay. Okay, so number one is less than 10%, still lots of shared results, still people voting. Okay, let's keep to the next one, 14. Do you believe the presented ALDREN building renovation passport proposal could be an interesting tool in terms of increased market success? Okay, lots of questions here. Okay, it's pretty clear. Skip to the next one. So, who do you think would be interested in the ALDREN building renovation passport?
Can you have one?
Okay, we can wait. Okay, we can show the results. Okay, that's very lot. Not everybody interesting. Still people voting.
So we have to
Okay.
go to the end.
Yeah. There are 4 left.
You take from your copy.
Okay, the last one, and then. So, what will be your feedback on the ALDREN renovation roadmaps? Well suited to the market needs, interesting but not sufficient, disconnected from market expectations, other or uncertain. Maybe if there is time, we can do the last 3 ones after hybrid, if we will find time. Can wait for the last 2 people, maybe, or not. Okay. This is uncertain. Okay. Thank you.
So is coffee and tea ready now? We have to be back here. We start sharp about 11 minutes. But you can bring your coffee and tea into our
Was there any questions you didn't get to one on the verification?
I didn't. You mean the one that we didn't ask?
Yes.
They are the last 3 ones that are the 17, 18, or 19. Is it something that's the same that you're asking me now? We can, because for this one we can ask maybe later after hybrid session. If I didn't answer your question, isn't it? Okay.
Do you remember that we submitted questions to the brief workshop? And
Yes.
you failed to ask them. You didn't realise that they were in the emails that we sent.
So, like, there were more questions to add to these ones?
Yes.
Okay, I think I didn't get them. Is it, how many there were?
I can't remember, but you were very apologetic at the time, saying that you hadn't realised that they were in the emails that we'd sent you.
Me? I was apologetic?
Yes.
Are you sure?
I think so, yeah. You are Mathieu?
Yes, it's
Yeah.
me.
I'll send you the email. So
Okay.
I say, it looks like, again, you have not included our questions.
Okay. Can you forward me that
Yeah.
mail? I'm sorry if I'm, but yeah.
Time we start in 10 minutes.
We start at 2:45 to 3. Yeah.
And then when can I now adjust the time for my presentation? Because I need to meet my students.
Okay.
What time is my presentation?
I don't recall it.
So after the meeting, we will go downtown, right? Back downtown. We meet at the downtown. Send me an email and let me know when I will be there. Is that it? Maybe my students will come.
November 12th to November 13th. So, Okay, but you can just send it forward this way so that yeah, sorry, because I didn't actually do summary they are because I changed the session.
So people have to connect again?
Yeah.
Okay.
Because I am building another section to separate them because it's more manageable than presentation. And then I can just launch it and we can start.
Yes. So you will have to connect to the link again because there's a new session that has been uploaded. So you have to connect one more time. So can I start from here? Just you start. Okay. So
on the screen here. This. Okay.
Okay. So now we go to the other Horizon project, which is called hybridGEOTABS. I'm going to explain a little about what TAPS is and give a little of the history. The TAPS is also what we call thermoactive building systems. That is where we, as you can see here, in a multi-story building, we integrate piping so we can activate either removing energy or supplying energy to the construction slab. So we use this as energy storage when we condition building. It's a little different from some of the other embedded pipe system where we can have it floor or wall or ceiling, but where the part that is heated or cooled are insulated from the main building. So to use the building structure for heating and cooling goes back several thousand years before Christ. Started like in China with the Kang, where they had the flue gas from cooking and so on the sitting area, and that's the way they heated the houses. And in Korea was basically the same, from the cooking pot, flue gases under the floor and up the chimney. So that was really an air-based system. That was also what the Romans were using. Now the floor has gone here for conditioning the Roman baths. The first, where we talk about the activated thermal slab, was about 1938. It was described in a German journal. And here, everything was mainly for heating, but it was steel pipes that were integrated into the concrete. There was a lot of welding and a lot of risk for getting leakage. But then it was reinvented in 1993, where Dow Chemical, they built a building in Switzerland, and a consulting engineer, Meyerhans, who is unfortunately is not with us anymore, he installed the TAP system, now with PEX pipes and circulating water. And from 1993, I worked with Meyerhans to develop this. And this is one of our first simulation calculations based on an Excel sheet, where we wanted to show one day you have input in the morning from load from people and sunshine. The air temperature increases, the operative temperature increases, the temperatures of the thermal construction slab increases, and the next day, if you don't do anything, you have about next morning 1 degree higher temperature, 1.5 degree higher temperature in the space. And then we said, okay, if we now circulate in the middle, keep that at 20 degrees, we can see we have a little lower temperature during the day, but the next morning we are back at 20 degrees. So that is possible to remove it by circulating water in the slab. But then we also looked at, yeah, but what if we don't circulate all the time? What if we just start, again, the same here, in the evening when people have gone to circulate, so we only circulate during the night, and we could see we could still remove all the heat. So that was the kind of the idea with this system, basically to use it mainly during nighttime, use the day to absorb it, energy, and remove most of it during nighttime. The first building after that in Germany, that the company I worked in that time, Velta, is now Uponor, was finished in 1998. And the floor looked like this. It was like a 15 centimeters concrete slab with pipes embedded. This was a two-story building built upon on top of another building. And already at that time, that's a building from the interior, very important with shading to keep the load down. But also there, we took measurement on the performance because everything was new. So we want really to try to document the performance by operative sensors in the working space. And we get what we know now from typically during the day, we have an increase of temperature, 22, 24, maybe up to 25. This is for July months in Stuttgart in Germany. And the return water temperature was about 21 degrees. Water temperatures was between 18 and 21 degrees. So the measurement also showed that it worked. One of the big questions that time is, what about the installation? How do we get the pipe into the concrete slab? Because at that time in Germany, most of the concrete was casted on site. And you have the people who put in the reinforcement. Remember, the pipes are normally between the upper and lower reinforcement. And if you come in with a new construction, so the HVAC people have to be there when they build the building, not when the building is finished, and you delay the others, then it will be very costly. So that was when we decided to make like a module of pipe and put that in. When the lower reinforcement was there, then it was put in, and then came the upper reinforcement. Another important thing was to make sure that you do a pressure test after an installation. Because on a building site like this, people, they will walk on the pipes, but they are strong enough, they can do that. But you see, you need to do a test. So the pressure test was very important for a guarantee. Now, later on, we see a prefabrication of slabs with integrated pipes. Also, we have a hollow pipe. That's a Danish manufacturer who can precast with piping. Now, when we have a better simulations tool, there has now been, everybody is doing simulations with these studies and are showing that it will work. But still, the main idea you see from this graph here, where you have the black one, is the load on the space during 24 hours. People come in, sunshine come in, and normally when you have an air system, you use the peak load to dimension your system. So the idea with the other system was that during daytime, you don't circulate water, you don't remove anything from the concrete, you absorb, but you remove with your ventilation air. You need a certain amount of ventilation for air quality, and that's how much you can remove. So that's the maximum load you need for the cooling for the air system. Then during nighttime, you don't need to ventilate that much. You start now cooling on the slab, and you circulate water there. And then the idea is that the area under these curves here should be the same or higher than the area under the load. And the other thing is that you need to make sure then that for example, the operative temperature in the space is within the comfort range, or the PMV values is within plus minus 0.5. So basically, you let it drift within that range. And that was also the measurement from the first building we made show that you do that. Since then, the next one was really a museum, but we see it now used mainly in offices. Very typical construction is this office 3-4 story high. And this one, in fact, has a geothermal. It has a heat pump. And it's made so that the heat pump can be bypassed during summertime, so just to use cooling from the ground. And if you both have heating and cooling, then you may keep the ground temperature at an equal temperature during the year. Also there was done measurement. Here you see the outside temperature goes up to about 34, 32, 33 degrees. And these are the temperature in different offices, and you see they keep them within up to a maximum of about 26 degrees. So there has been many indications showing that the system do work. It has then penetrated into other countries, of course not as much as it has in the Middle Europe, but also in other countries. Here, for example, Beirut, Lebanon, the American University, in a new building, they have a TAPS system there. There's also both in hospitals and train stations and other types of buildings. The only study I know where you in exactly the same building have studied a TAPS system, here's radiant cooling, is a building in Hyderabad, where the engineering company decided one part of the building would be with a TAPS system, and the other part would be with an air system, a VAV system. And then they, over a couple of years, did measurement of the energy. They also measured the indoor comfort, and they had a third party to look at the measurement. And when we look at the two, the building heights, you see, were the same. But in the room where they didn't have the suspended ceilings for the air system, you would have a higher ceiling height, except where you had a beam here. You would have a higher ceiling height, so you could have more daylight penetrating into the room. The alternative is you can keep the same room height, but then you save building material, about 50, 60 centimeters of building material for each story. Their measurements showed that the building in general was a very low energy building measured with Indian relation to other building in India. So it was not like one was very bad and the other side was very good. It was basically the same construction. And the radiant system, the TAPS system, still had about 35% better energy performance than the VAV system. Also, when we looked at the comfort, the radiants are here. They are in a more narrow range. The black one is a wider range. And you can even see it was not because the temperatures in the radiant were much higher than in the other part. They were really lower. You could have increased the temperature and saved even more energy. The last country where it's coming into now is Japan, one of the biggest, or the biggest design company in Japan. It's a design company, have both engineers and architects. They wanted to use the system in a new building that was opened last year. They have very special types of taps, but they have piping integrated here. And then in between, they have air supply and lighting, and they try basically to keep the surface temperature around 20 degrees and 26 degrees in the space. And right now, it's being doing measurement also in this building. There has been some reluctance to do it in this part because Tokyo gets very humid also in summertime. But the first years of measurement show very good results, so I think there will be an increase in market also there. So, thank you.
Thank you very much, Bjarne. We're two of us. One without slides, so you use your own imagination, and my words, and one that Jelle will show and goes further on my short story. Bjarne showed us it's quite a sexy concept, even only on the TAPS issue. You have big surfaces, moderate system temperatures, and it's rather robust, and you have degrees of flexibility. So for me, as an engineer who's designing concepts, choosing concepts, and in a time frame where sustainability, where renewable energy sources and using them actively in buildings and optimizing them, the use in buildings, is quite important. Of course, the temperature levels in the concrete slabs are quite good to integrate in such a system. So you might say that the talk of Bjarne, but let's say the first talks just in the former century, inspired to use it in combination with renewable systems. So the geothermal application was one of the systems that really fitted into this concept of taps. So we did a lot of those buildings. It's rather easy to design them. That's not a big problem. It's rather robust. You have to look at a lot of aspects, the building aspects, the use aspects. But okay, if you can convince somebody to invest, it's not such a high investment. It's a very good sustainable solution. But on the other hand, if we see a lot of buildings put down there, you see that the optimal potential, the best way to use the renewable energy to really minimize it as far as it can be minimized is not always achieved, because everybody is happy. Once the building is there, okay, you need a little bit tuning, but on the comfort side, there's seldomly a problem. Okay? If you want to go further, if you want to go towards the optimum of the energy potential, then there's still a big job to be done. So let's say, having some buildings put down in the market, after 10 years, there was a professor at the KU Leuven who wanted to look at it, not the combination of elements, but just how does the system as such work. And that was Professor Helsen. And she created the name GEOTABS, so the geothermal heat pump together with the taps, as Bjarne mentioned. And that project discovered that the potential was far more than what we used to achieve in the market as it was at that moment. And that confirmed that even if it was a nice fairy tale, like a good match between emission system and renewable supply system, that we could go much further. And going much further gave us some specification of what are the problems that we need to solve to get a full deployment of the market. And one of them was the operation versus the control. So how can we improve the control to not worry about it, that we'll get the optimal operation or close to it. The second one is too good to be true. You can shortly explain, and mostly people are convinced we'll do it. But that's not the case. Most of the people will say, okay, I'm making a big choice now. You have to quantify what my advantages are. We do not only want the story, show me, calculate. So we have to do that in a very early phase. And the next thing is, if you want to be sure you use it for a lot of buildings, not all buildings are office buildings, then sometimes you need to look at the fact that the cooling load, the heating load, of course also depending on the climate, it's not equally balanced. So you could need another system to make a hybrid GEOTABS system. And how do you control it? And how do you optimally design it? So these are three main questions. And let's translate it towards the hybridGEOTABS project, where Jelle will say what we are doing. Two main questions are, how can we fast, in an early phase of the project, quantify the advantages of the hybridGEOTABS system? And secondly, a main pillar of the project, how can we create an operation, a control system that does not force the engineer to go there every 3 months to see if everything is working as he had hoped and dreamed it would work. So I present you Jelle Laverge, professor at Ghent University and young blood in hybridGEOTABS story.
Okay, so Wim and Bjarne nicely addressed what the history of leading up to this project was. And so the main goal of this project was to address some of the challenges towards mass market implementation of the concept that Wim just highlighted. And so when we proposed this project, we took out 4 of these challenges, or specified 4 of these challenges, and I grouped them here in 2 groups. The first one are related to design. And so basically, if you want to convince a client that they should opt for a GEOTABS building, there are 2 big issues. First issue is that although the taps as such are rather cheap, because they're reusing a structural element also as a emission element, for a GEOTABS concept, they are combined with a geothermal heat pump, and there the geothermal heat exchanger is a big investment. So there's a large investment cost that is then later, of course, offset by a low operational cost. But in a mass market situation, it's often difficult to convince a potential or a future building owner that they should invest more and that they will get that gain back, as Wim said earlier. That's one issue related to design. So if we can design or create a design strategy that minimizes the cost for the ground source heat exchanger, that is a big plus. So that's one of the goals we're aiming for. Second challenge related to design is the engineering costs. As Wim also introduced, to convince the client, you need a lot of calculated material, and when you're in a competition between design companies with different design proposals, and you want to convince the client to choose your concept and your company, the fact that you have a lot of upfront engineering work to do to come up with all of these figures and to convince the client is a real barrier in terms of being able to target lots of different potential building owners. And so, again, if you want to go to mass market implementation, we need to lower the engineering costs. That's challenges related to design. 2 other challenges that we wanted to tackle are more related to operation. Again, Wim introduced this very nicely. If you want to have a reliable control for TAP systems, and you look into the literature and the experience from previous projects, basically what you see is that the set points and how you control the system are rather sensitive, so you need a long commissioning period to be able to really fine-tune the control to the specific use of the building after it has been delivered. So that again is substantial costs that we want to try to address. And one of the ways forward to address this that was identified in the previous project was that MPC, Model Predictive Control, is a good way to offset that cost, because there you have a model that is included in your controller, and it will automatically look for the good set points, the good way of controlling the system. The problem there is that at that point, the existing approaches for model predictive control basically relied on information coming from the building management system, so sensors in the system, to calibrate its own model and then come up with a good solution. And the problem there is that you need the system operational to be able to start the model predictive control algorithm, which of course doesn't relieve the designer from the effort of doing the commissioning, because you need to first have the building operational before you can then install the MPC to then avoid the commissioning cost, which doesn't work. So overcoming this was basically the main challenge for the operational part of our project. And so we had a proposal for two types of solutions. One was to have a design method that basically bypasses all of the, or a large part of the need for specific tailored simulations during the design phase to size the different components of the concept. So the secondary system, the ground source heat exchange, the heat pump. And the way we are doing this is by doing a whole lot of simulations that strategically represent what we feel are relevant building types and relevant building sizes and relevant building parameters, so that we can cover the most important part of the relevant building markets. And so that if a designer then wants to design such a building, you can fall back on the pre-calculated results that we have to come to a quick sizing and then do a detailed sizing once the contract has been awarded. That's for the design. For the operation, the idea within KU Leuven was to develop a white box MPC, so an MPC that is purely based on a description of the building with information that is available during the design stage. And by doing that, we no longer need this measured data to start the MPC process, and the MPC can be installed and run directly from the delivery of the building. So that's what our goals are. We're working hard on that. We're focusing on 4 types of non-residential buildings, so offices, which are like the first birthplace of TAPS, let's say. And then we're expanding to schools, elderly homes, and large multifamily residential buildings. Now, we'll have 2 sneak peeks, let's say, into the different parts of the project. I'm going to give a first small intro in what we're doing in terms of the design process, and then Iri will give some longer explanation about the MPC.
1 minute.
Yep, we'll get there. So this is the process we're using. We're using building stock data. We're translating that into a building that more or less looks like a building from that size, but which is generic. We're doing simulations, and then from that we're deriving relevant information for the sizing. This is an example. You see 3 lines. The orange line is the predicted heat load for the heating and cooling load for the building, and then using an algorithm that we developed, we're splitting this into a heat load that goes to the taps and a heat load that goes to the secondary system. Taps is red. Blue is the secondary system. And then based on that, we are sizing the secondary system, and we're using more traditional methods based on load duration curves to also size the ground source heat exchanger and the heat pump. And then from that, we're working towards market-ready product packages and a design method that is easy to follow by an unexperienced design engineer. And so, next is Irje.
Good afternoon, ladies and gentlemen. So my name is Jiří Cigler. I'm from Energo Cluster from Czech Republic. And my talk is about model operative control for HVAC systems. Briefly, it was presented by Jelle, so you already know what is MPC. But I will add that it's generally advanced process control method, which is suitable mainly for complex multiple input and multiple output systems. what and why it is suitable for these systems? It's mainly because for these systems it's very difficult to find some simple rules how to operate these systems. For example, you can imagine that if you have 10 inputs which influence 20 outputs, then it's difficult to find a mapping or some function which will take these inputs and the outputs and control these inputs. So that's why we have this advanced method, and you can imagine that this method is if the name contains model, it's model-based, which means that we have mathematical equations describing the process that we are controlling. Okay, so we have the equations, as you see here on the graph. So in the case of buildings, we have a heat transfer model. And then we have some calculation method. In our case, it's numerical optimization, which seeks from in the space of all possible control actions, the best control action, which minimizes some criteria. So we have also some comfort criteria that we want to optimize. It can be, for example, minimization of energy, delivered energy. It can be minimization of CO2 footprint. It can be minimization of price, what we pay for the energy. That's the reason why it also can include the energy prices. This is like very, very suitable in the case of smart grids, where the price can change quite a lot between hours. And the control actions in the case of buildings are taken also based on the forecast of weather, solar radiation, temperature, occupancy in next hours. So if we know that it will, for example, be sunny day in a transition period, it's suitable, or the MPC knows that it's not necessary, it might not be necessary to heat up the building, because in a couple hours some people will come, it will produce heat, internal gains, and also it will be sunny days, so at the end it's the control action which would be taken by a regular controller. It means normal heating is not good control action, and MPC doesn't do that. So MPC basically anticipates the control actions based on all these parameters. And very important thing on MPC is that it also can include constraints. So we can include any kind of constraint. For example, that we want to have supply temperature only 40 degrees, or this kind of things. With regards to energy and buildings, I have to say that it has possible applications not only for hybrid GEOTABS buildings, which are as such complex, but generally it makes sense for energy systems where there are multiple energy sources, which means that, for example, if we have heat pump, gas boiler, and chiller, and another heat pump. So in this case, the decision task is how to operate these technologies on which power. So in this case, this is like very good optimization task, especially when there are some thermal storages or electrical storages, including batteries and so on. Then we have smart grid and connected systems. Very good example is district heating system, where basically every part of the district heating system influences the other part of the system. So it's, I would say, connected system. So it's also good to look on this system from a multi-dimensional point of view. And we can also have complex control objectives. In the projects we are, for example, talking about minimization of PMV index, or minimization of predicted percentage of dissatisfied, which is like the index which gives us some information about the indoor environment quality. So, so this is like very complex thing. It's a mathematical formula which can hardly be included into classical control algorithms. Yes, and if I compare the traditional classical control algorithms to MBC, then basically in the case of traditional algorithm, we have some visualization, it's called SCADA interface. It's a monitor with the scheme of the technology, and then we have in the case of bigger buildings, we have a main controller which contains some if-else conditions. If this condition is true, then, for example, run heat pump. And then there is another, for example, feed-forward rule, which gives the information, okay, the outside temperature is plus 25. It means that it's necessary to cool the supply temperature to 15 degrees, and so on. And so that there is the main controller, and then there are subcontrollers. For example, for air handling unit 1, 2, 3, so there can be like tens of subcontrollers. But what is important that typically there is like one central point where we have all the data. So for these, based on, we can extend this control scheme with MPC in the following way. Basically, the main controller is not containing the if-else rules, but it contains this optimization of complete operation of the building, and the previously used main controller is basically only a data points concentrator, which serves for the communication between the software of MPC, which is really a software as we know it from the notion of the word software, which communicates through this data point concentrator with the subcontrollers. And the remainder of the system is actually the same. So it's necessary to install this software to the building. What are the benefits and the disadvantages of this approach? Basically, as was already mentioned, when you have the model, then the commissioning of the MPC is very fast. Compared, in the case of GEOTABS buildings, it's very hard to tune the heating curve controller for supply water to the taps. In the case of MPC, if you have valid model with valid predictions, then basically it's immediately or almost immediately implemented. Yeah, but it's important to say that to get the model, it takes some time, and that's basically the biggest disadvantage of this approach. Normally, normally it takes, for example, 70% or 80% of time, of the implementation time, to develop this model. And in this project, we focus also on speeding up of this modeling phase. That's the reason why we try to use the white box approach, the calibrated and validated standalone components, just putting together and obtain one big model of the building, which can be used directly in the MPC.
1 minute.
Okay. And yes. So next, the benefits. It's also validation of critical situations in advance. More precise set point tracking. In all cases where MPC was implemented, the comfort was better than with previous control strategies. Energy efficiency and diagnostics. So these are the buildings which already have MPC. There is one in Belgium, in France, in Brussels. It's office building with complete white box model. It's quite a new MPC, so sometimes it's switched back. But I think that in a couple of weeks it will be in normal operation, I would say. And then we have School Liebesnice, where we have MPC from 2015. and it's basically from the first day when the building was opened. It's in the Czech Republic. This building has a ground-coupled heat pump with complete GEOTAP system. Then we have 2 buildings in Prague, Czech Republic, which have only taps. But on these buildings, we achieved savings 20% or 23%, and improved comfort. What's also interesting is that basically NPC can lower the peak load of the building. In, for example, this case, it was lowered by 50%. So that, the control actions were smooth compared to the previous controller. So that's all from my side.
Thank you. Next, Pavel will be back.
So good afternoon. It's not about ALDREN. I have a different hat on. So I was asked to tell a few words about indoor environmental quality, productivity, and health in connection with GEOTABS. And I will continue with the same manner as the 2 presentations before. I give you a short course on the productivity and health. So let's start with the productivity. So there is sufficient evidence in the scientific literature to show that indoor environmental quality affects the performance of work. And first of all, productivity, it's a sexy term. Everyone likes to use it, but probably it is not addressing what is happening here. What we will be talking about is the performance on how efficiently we work, or how efficiently we use our abilities to perform what we are supposed to do, rather than productivity is more economic. So, coming back, there is sufficient evidence to show that indoor environment has an effect on how we work. Not only this, how quickly we recover in hospitals, how well we learn in schools. And this is a slide that I took from the World Green Building Council report, and it's available, to everyone on internet. That clearly shows what we know, the current state of knowledge on the effects on performance. And you can see that those effects, they can even be up to 40%, but from the low level of few percent. So it's a few percent of 40%. So we know the range, so we know it's important. But of course, the most important is how can we use it in practice? So we need to have a certain relationships between certain parameters that define indoor environmental quality and work performance. And to this end, we have very little, actually. So the only few that exist, I will show, is one is on the effects of temperature and performance of office work. And it's only applicable in the temperate climates, because it's the data from temperate climates, and maybe conditioned spaces, air-conditioned spaces, I would say. And it shows that there is a certain optimal level of temperature at which we perform our work well. And then if you go outside that range, the performance will decrease. And then you see this is a relationship that is based both on the lab study and the field measurements, using different methods of quantifying what is called performance here on the y-axis. And but anyway, it can be used for modeling and prediction. This, of course, cannot be generalized to other climates unless we use other term of a thermal to express the thermal effect, and then that can be a thermal sensation. So there is similar relationship based on a less, not that many data that for the one that I presented, that relates the thermal sensation vote of our thermal sensation with the performance. And here we see that we perform best or most optimal when we are slightly below neutral. Slightly, so it's not be cold, but slightly below neutral. With respect to air quality then, we don't have a marker of air quality. Air quality is undefined, so we define it by proxies. One of the proxies that is defining air quality is the ventilation. And for that, we have a relation that defines the change in our work efficiency with respect to the amount of air that is supplied, assuming that the air, the more ventilation, the better air quality. And this is not the inverted U-shaped curve, but it is a logarithmic curve. And you see, if you have buildings with good air quality, the effects will be small. With you have buildings with poor air quality, improving air quality will provide you with large increases in performance, work performance. So generally, we say it's about 5 to 10%. For ventilation, about doubling ventilation or improving air quality by 2 times will be about 2%. And then for the temperatures, about 1 degree, it's about 1% to 2%. So within the ranges that we observe normally in buildings, this is what we expect, 5 to 10%. What else we know? We know the mechanisms, or we suppose that what are the mechanisms underlying those effects. So basically, they can be grouped in 3 different classes. One class is a certain distraction, motivation, and motivation to perform work. The other is the symptoms that we perceive. I mean, that could be symptoms that we have a headache, or we are tired, or maybe we have runny nose, and so on and so on. So this is, and then there are 2 here aspects that are also affecting our performance is our sleep quality, not very well discussed, and there's not much evidence on that. And also when we are absent from work because we cannot work because the environment is poor, then also it will also affect the productivity in the end. So this information has been summarized. You can read it in some examples of the publications in which you can read more about those relationships. Basically, not much new has been coming in the last year, so these are still relevant publications. But we still have challenges. So we know that there is this relation, but the question is how we can reliably measure performance. We don't have a performance meter like energy meter, right, or thermometer. We don't have that. So we don't know which pollutants are associated with effects on performance. And, and how we can use this evidence in the economic calculations. So there is certain reluctancy to use these parameters because, maybe they are not that accurate and so on and so on. With respect to indoor environmental quality, we never expose to one parameter at a time. We never expose temperature alone, and air quality alone, noise alone, light alone, and so on and so on. So we don't know what is a combined effect. So if there is an effect of temperature, air quality, noise, and light. So what is a combined effect? We don't know. And then what are the risks associated with adaptive thermal comfort model? And are there any benefits of the so-called green buildings or the buildings which perform well with respect to energy on performance? Very little information on that. What we do know, that if we ask occupants of a building and ask them which parameters are important for your performance, so they will say temperature, noise level, air quality, and visual comfort. These are top parameters. If the same people will be asked, what is important for my comfort? Amount of space, colors and textures, ease of interaction, temperature may be lower, air quality lower. So, I mean, you can see this is a design objective. Comfort is a design objective, or the work performance is a design objective. Health, very quickly. This health is more complicated because how do we define health? So we define it as a, how we define the term health. So health defined by WHO is the absence of any disease and infirmity and so on and so on. But I mean, this is a well-being, general well-being. But in medical terms, it's differently defined. So there is a debate how to do it. So I'll say a few words only about health, how indoor environmental quality is related to health. I think the best data comes from the indoor air quality aspects. and that is an example of that, is the burden of disease that is associated with the exposure to air pollutants indoors. So because we spend most of the time indoor, we are also exposed to the ambient air indoors, which penetrates the buildings, right? And there are other, so the burden of disease, not even going into the details what are the elements, is about 2 million healthy lives in Europe every year lost. This is measurable or tangible health effects. So 2 million healthy lives, which is, the metric is DALI, disability adjusted life, yes, used by WHO. So this estimate, if we assume that it's about 100,000 euro is a one life, I mean, if you can, of course, put the number on this, and the estimates are comparable with DALIs that are lost to road traffic in European region. That is an example from 2002. And if you put this 100 euro as 1,000 euro, the cost of the 2 million life lost every year is GDP of a Cyprus. So this is an example. In France, the estimation was done is about 20 billion euro annually. So this is one aspect of this. But this can be done on a population basis. So how you can do it at the building level? So at the building level, what we use is so-called self-rated or self-ST reported acute health symptoms. So people who report that they have a headache, a runny nose, they're fatigued, are sleepy, don't want to work because environment is poor and so on. So all those kind of symptoms, and the symptomatology has been related, or the number of symptoms has been related both to the air quality, here represented as the ventilation, and also to the temperature. So elevated temperature and reduced ventilation or poor air quality will increase the symptomatology. So people will report more symptoms. The question is how you can convert it into a financial benefit. It's more difficult. Then the metric that is used is the absence rate also. So when we are absent because we are sick or lightly sick, now we are also talking about presenteeism. This is absenteeism, but we also talk about presenteeism. People who are sick come to work not to lose their work, right? So there are two terms here. So with respect to absence rates, about 1 to 2 days to the total on average. There are no relationships. The only relationship here for the air quality is this one, and it's based most of the modeling and very, 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 very few data. So we don't know how accurate it is. So finally, this 30 seconds, how we sleep is very important on how we perform the next day. And this is the least researched topic with respect to indoor environmental quality. So we know a lot about schools, offices, dwellings, but we don't know about the bedroom in dwellings. So it's vital for life, for health, for performance, and everything. It's extremely important. So we have very little evidence. We know that elevated temperatures are not good for our sleep quality, and poorer quality is also not good for our sleep quality. And it has a measurable effect on the next day performance. Thank you.
Thank you. Let's do our last presentation. Innovations in radiant heating and cooling system using ECN.
Yep. Okay, so I have my timer, but just in case.
You don't need it.
So, well, good afternoon once again. I hope everybody's still awake. It's the last presentation, and the title is Innovations in Radiant Heating and Cooling Systems, Use of Phase Change Materials. So we've heard recently from Paul and before from other presenters about tabs and radiants and different systems. So before I get into the PCMs and why they're good and why can we use them, just to, again, wrap up the big picture, is that we spend most of our lives indoors, which basically means that buildings, they're built for us, for people, and not for saving or conserving energy. Because if there were fewer buildings, then there would be
more energy savings. So comfort, health, and productivity of the building occupants should be achieved with the possible energy use, and then if possible with renewable energy resources instead of fossil fuels. So, and heating, cooling, and ventilation systems or mechanical systems, they allow us to control indoor environments. And radiant water-based heating and cooling systems are one type of these mechanical heating and cooling systems. So we've heard, so I'll not get into so much details, but radiant heating and cooling systems, they work with the low temperature heating and high temperature cooling principle, which means that the temperatures, the water temperatures that you use are close to the room temperatures. They're water-based, and there are three main types. We've heard about tabs from Jana. In addition to that, there's also radiant heating and cooling panels and other systems that are in the building structure, but not in the main structure of the building. So these are more like floor heating systems, for example. And again, this is also, I took this from Jana, as you've seen before. So this is panel, which is usually hanging from a ceiling, so it's decoupled from the building structure. Floor, wall, and ceiling systems, they are integrated into the building, but not in the main structure of the building. And then the last one is tabs, thermally active building systems, where you activate the building structure. So there are several benefits. Normally these bullet points should come one at a time, so there shouldn't be so many text on one slide, but here we are. So they have several benefits. They allow integration of renewable energy resources because of the good match with working temperatures. They allow transferring peak loads to off-peak hours and possible peak load reductions. Favorable operating conditions for heating and cooling plants, so for heat pumps, for example. Reduce total energy use, less space requirement, and more flexible since there is no, let's say, visible room terminal units, and so forth. So they have several benefits. I will not get into each one of them. So we want to have a system that is not tabs, but can provide similar benefits to tabs. And we can use that also in renovation of buildings. So not only in new buildings like tabs, but also in renovation of buildings. So what is the system? One option is radiant ceiling panels with phase change materials. So what are phase change materials? They could be organic or inorganic materials. They mainly work with the utilization of the latent heat, or at least that's the part that we benefit from them the most. They could be used passively or actively. Actively means that you control their charging or discharging behavior. They allow thermal mass enhancement, also temperature control of indoor spaces, which then means that you can manage the cooling load. And as I mentioned, also one potential in addition to the renovation of buildings is also the possibility to use in lightweight buildings. So the main goals of our work is to develop a new product, which is the phase change material including PCM, or the ceiling panels including PCM, to address implementation limitations and constraints in renovation and in new buildings, because it can also be applied in new buildings. And before we can, let's say, get to the market for market penetration, we need to address these concerns. And it can't be that if you need, let's say, 3 years or a PhD to find out how the PCM panels work, it will never get to the market. So we need to figure out a better way for people, or an easier way for people to be able to use them, integrate them in their, let's say, possible projects. So we need to come up with some performance or characteristic curves. And in order to do that, we are doing climate chamber measurements and parametric analysis through dynamic building simulation tools. So this is a picture of the new PCM panel. It looks like any other panel, but it's not. It has PCM inside. And one of our main ideas was to use existing products that you can find on the market and combine them in an innovative way, so you get to a new product that does not exist on the market. And this is the result of that. It was a big challenge to get it to be, let's say, leak-free. So even though it looks very simple like a box, there was a lot of work involved in it. But anyway, so this is the product that we came up with. There's piping inside, so it's kind of modified from an existing product that is basically radiant ceiling panel. So normally you will have no thermal mass, and normally you will have a very minimum resistance from the water to the surface as a principle of radiant panels. So, okay, very good. So I'll show some preliminary results, or let's say some of our first results. You may have heard that PCM ceiling panels work like taps, but we have not found so many, or let's say any study that can actually prove that. And when we say they work like taps, what do we mean? What I mean is in terms of energy performance, in terms of the created indoor environment, and in terms of how they remove heat, or the heat removal mechanism from the space. Is it similar to taps or no? Well, the answer is yes, and we were able to show this initially with simulation results. So these are the ones that you see. And basically what we can see is the first graph right here is showing the energy use results, PCM, all air, and taps. It's conditioning of a same office space for 24 occupants, and the room space of 53 square meters, so very high cooling load, I must say. So we can see that both PCM and taps, they perform similar in terms of energy performance. That is roughly 20% lower than the all air. And you can also see that the energy use of different components in the system are very similar between PCM and taps. One thing that is not shown here is that also the amount of heat removed by the ceiling surface in both PCM and taps, they were very close. That was around 60 to 65% of the total heat removed from the room. Then, also in terms of the created indoor environment, we can see that they were very close. These correspond to the indoor environment categories according to the EN standard 16798. And we can see again that the different categories are quite similar. So we have some ongoing work. As I said, these were supposed to show one at a time. So basically, these panels that I just showed, we've installed them in a climate chamber, in one of our climate chamber, which allows us to control the indoor environment conditions, so we can get, let's say, realistic operation conditions and parameters, performance of these panels. Now we have this room configured as a two-person's office room, so we use we simulate occupants, their computers. There's light and heat loads or heat gains from the window surface. We will be testing different conditions, for example, different supply water temperatures, supply flow rates, different cooling loads in the room to extract the performance curves, and basically to help designers or practitioners in an easier way to implement the PCM panels in real projects. And this is basically it's called a panoramic picture of the climate chamber. So to summarize, we have now showed with simulations, but now we will move on to show it through experiments that the PCM ceiling panels indeed do work like taps, so they can provide similar benefits to taps. They're applicable in renovation of buildings, at least now in theory. And one thing I didn't mention, but they also have the possibility of being coupled to renewable energy resources. And in this case, I mean PVT, which is photovoltaic and thermal panels, which we are more interested during the nighttime operation for night radiative cooling purposes. So the PCM panels, they are coupled to photovoltaic and thermal panels in the roof of our climate chamber or of our building to see the potential of night radiative cooling. So there are some things needed before we can really fully advocate for PCM panels being implemented in buildings and saying that they can be used, and there you go. So first, design dimensioning and control methodology are needed. As I said, if you need a PhD to install this or to use this in reality, it will not work. Working and successful examples are needed. Most of the studies or the results that we see are either short-term measurements or climate chamber measurements. So some working examples from real life are needed before people are convinced. This goes together with the long-term measurements, so you can actually see that it's installed in a building, it works, it's controllable, and so forth. And detailed economic analysis are needed. So we've done some work on this. We've showed that compared to tabs and all air, it's not as expensive as people claim to be. And for a high cooling load of 60-70 watt per square meter, we showed that it's only 5% more expensive than tabs and, sorry, more expensive than all air solution. Tabs was cheaper in that case. So that would be all, and I would just like to acknowledge some of my colleagues and our project. Thank you.
Thank you. So that ends the presentation. Now we go to presentation and look at some further questions.
Yeah, we have a few questions for hybridGEOTABS. So yeah. So okay. Okay, we can start with the first one. So, how familiar were you with GEOTABS technology before the session? Not familiar. I heard about the concept, I understand the concept, or I have experience with the concept. Now we will check for the first slide how many votes we have, so count them for the next ones. I think maybe we are less than the previous one. Can you see it? You cannot see it? You can try to restart it and use the same link on the top. Is it working now? So we have total of 11, maybe some more. Okay, I can show this one. Okay. So let's skip to the next one. So for which building type would you apply GEOTABS? All, office, residential, school, multifamily, don't know. We had like 15 votes the previous one, so maybe we can stick to this number, 14, 15. Is it working, Peppa? Okay. Is it fine?
When you did it, then it comes that's after you vote. Yeah, it's after voting. Yeah.
Okay.
If you have voted, you're okay.
Okay, I can show. Okay, so most of this. Okay, let's skip to the next one. So, what is your opinion on MBC for building control? Too complex, large potential, very excited, not realistic, don't know. Okay, I think 13 can be enough. 14. Okay. Okay, so large potential is the one. Looking to the next one, the fourth one. So, is the building sector ready for MPC? Yes, now, in 2 years, in 5 years, in more than 5 years, or don't know. Okay, 15 is enough, I think. Okay, so there is a shared outcomes between don't know and in 5 years. Okay. So the next one, what is the main potential of MPC? Robustness, thermal comfort, energy use reduction, setup and commissioning efficiency, or don't know? Can wait for 14 maybe. Okay. Energy use reduction. Interesting. Still some votes. Okay, can skip to the next one. So, what is the main challenge to bring GEOTABS to market? Design challenges, capital cost, commissioning. There is no challenge, or don't know? Okay, 14 I think is enough. Okay, capital cost is the main shared reply one. Okay, I think we are 15. Okay, let's get to the next one. So, what, in your opinion, is GEOTABS' greatest strength? Energy saving, heat saving, grid services, comfort, optimized operation, better space utilization, or other?
And you can have multiple choices. Yes.
Wait, 15 maybe? 14, 15, 16, okay. Okay, skip to the, this is the last one. So, do you feel hybridGEOTABS can now be expressed in the ALDREN Evaluation Scheme? Yes, now, not at all, not yet, or don't know? Okay, I think I showed the result. Okay, so this was the last one, but we have 2 questions from the attendees from the ALDREN session and 1 from hybridGEOTABS. The 2 ones from ALDREN, I just can read them without showing because it's the previous session, but we can start with the ALDREN ones. So the first one is there a defined NZ on EU level or only on national values? Yeah, I mean, I was watching you on, but everybody. Yeah, it's a question for everybody that wants to.
Because Jana, you are referring to N7. There is a microphone.
Oh yeah, sure.
Because if we want to have it so they can hear online. No, it's online.
No, you can come here. Yeah, you can start here.
This one is also. So, as I said, that ALDREN nearly zero energy building is close to definition by member states, but it is not exactly national definition. But we try to use recommendation by Commission for values because there is recommendation, legal document by Commission, there are some values. So we are close, but we check it also on our model building that we use the national values for thermal envelope and systems, and now we check these values. But they are not exactly national values.
There cannot be national values. There cannot be a European value, so it can be only a recommendation. And there is a recommendation from the Commission how to define a nearly zero energy building. Yes, and that is the one thing we should use. Yes, exactly. This is where Jana referred to. Try to use the microphone.
Yeah, I think this is working nice.
So yes, it is. Just a quick comment that the European Green Building Councils are also defining zero energy buildings for the World Green Building Council. So there is national definitions being developed at the moment, and I don't know if there's anyone here from the Netherlands. No? The Dutch Green Building Council has come up with a definition called Paris-proof concept, which is really interesting. If you Google Dutch GBC Paris-proof concept, it's really worthwhile.
Okay, can I go to the second question? That is, should the renovation passport use or integrate BIM? Somebody wants to reply?
Yes. For sure, within the ALDREN procedure, we are going to investigate even that aspect. That's the reason why the module, one of the module of the build log is named documentation and BIM. It's definitely another big issue to investigate, but the desire of ALDREN is to go on that path for sure.
Then there is a question for hybridGEOTABS. I can show it here. I think it's okay. Will an MPC also register all sensors, room system, outdoor, so it can be used as a continuous maintenance tool?
This was already answered in the next slide.
I put the question before you showed it.
Okay. Okay.
There's a two of the question.
Can I ask a question? I was wanting to ask, how do you deal with the fresh air in geotabs? Because you seem to be using conditioning for the space heating, but what about the fresh air? There is a system called Thermodat you must be aware of, which uses the slab to condition the fresh air.
Yeah, we don't want that. No.
Well, there's always a ventilation system. And often in building with taps, this is used also as a secondary system to provide some cooling, and if you need dehumidification. So that's always there. But in some cases, they may have a second heating system also. But mainly it's the air system which you have for the ventilation that is being used. So, but to use air to heat or cool the slabs. I know this was first introduced in Sweden many years ago, and I know there's a company in the UK who is promoting it. The difference is that here you still carry the energy with the air. And we want to carry so much of the energy as possible with water because it's much more energy efficient. So there has also been some discussion, what about how clean is the canals you have in the concrete, what are the risks for bad indoor air quality and so on.
So, yeah, question from the presenter are over, so if you still want to keep on going with other discussion.
Yes, so still have time and nothing else to do. So, yes, Johan.
I have just one question. I think I was very much interested by this. First of all, my one question is, I didn't understand why these phase-changing materials are connected to PV, especially in the night. Maybe I have some difficulties to understand this. And the second question was, maybe I will say that both questions at the same time. If this phase change material panels, if they are already commercialized or not.
Okay. Okay. So just the order. So the main idea is it was like too quickly in the end. So I understand why it was not clear. So the main idea is that we have the PCM panels in the room. So they remove the heat from the room. So basically, you need to get rid of that heat somehow. So what we are trying is that we have the solar panel, or the photovoltaic and thermal panels in the roof. And but just for the sake of completeness. So normally you would install them for electricity, and if you have the T, you can get also some, let's say, heat out of it. But you can also use them in the night for cooling if you circulate water, because in the night it will be radiating heat to the sky. T.
PVT.
PVT.
Yeah, it's the T that's important here.
Yeah. So basically, so it's all okay. Okay. But anyway, we have some storage tanks in between, so they are not directly connected to the PCM panels. The second one is that the one that I showed and the ones that we are testing, they are the only examples or the only samples in the world that they exist, so they are not commercialized. That is the that's the idea. So basically, we took what's existing, tried to combine them, found out that obviously what exists is not optimal for our purposes, so we had to do a lot of tests, and it took a lot of time. But that's the idea in the future.
But there are
other panels.
They are on the market. The first we used, we'd also had the possibility to buffer humidity. It was a commercial product which is on the market.
Yes.
There is one from here on the market, which is about the gypsum panels with this very small hole.
Yes, but are there piping in it?
No, it's not.
No, we are only talking of those you can activate by having the piping. The problem with PCM, if you can use them as passive, and then maybe use night air cooling to generate or make them solid again. But their heat conductivity is so bad So you need to have very good connection to where you want to remove or supply heat.
The only point was when I see that these panels, for example, these BASF panels, which are these gypsum panels, are already available, and I didn't see that it is so much complicated just to integrate some pipes, and then the work is done. But maybe I see it in a little bit too easy a way.
Just is the keyword. It's not just. The way I show, maybe it seems like just, but it's not.
But we did look at that, because we took one of those gypsum net boards and just had a standard kind of metal suspended radiant panels, and then we said, okay, the easy way is to take existing products. So we took this gypsum. How thick were they? 2 centimeters or 1.5? Yes, and put them. Make a good contact with the metal surface of the radiant panel, but it didn't work that well because of the heat conductivity. Yes. So the best is to get the piping inside. Yes.
We want something we can control as like that. So there are different ways as you explained. So it's not just to increase the thermal inertia or thermal mass in the room, but to have something that we can control.
There has been some ideas also to increase conductivity by having like a graphite within the construction, but the prices just go up. It becomes very expensive.
Yes, 2 questions from the side of costs. The first one is, who is going to sell the MPC solution that you're developing as a package? So how will it be packaged, and maybe which partner in the project is working on that, and how do you plan to do this market uptake after the project? And the second question is, what do you think, what do you know already about the cost effectiveness of MPC controls, and maybe also about PCM, depending on the starting current state of the building? Because if the building is already very performant, I guess there may be, I saw before 20% gain in energy consumption, but maybe if your building is with a higher consumption, then I guess the relative savings is maybe only 5% or 10%.
Thierry? Did you get the question?
Yeah, I listened to the questions. First question was on the commercialization, right?
Yes.
Yeah, so basically it's an Energo cluster or a new company, new startup company of Philip, Taco, if I remember well. So I think at the end, very good business plan would be like for in the case of new buildings, to design and build the building in one team. So basically it will be one guy who or one person, one company who will develop the model that can be used also for the validation of the design. And then this model can be used directly in the MPC. Then it makes sense, because I think there is a big cost saving on this development and on the commissioning of the system, because then it really doesn't take 2 years to commission TAPS system, but it takes 1 month, 2 months to set up all communications and everything, and then it should work. Yeah. And what was the second question?
The potential for saving energy if you have already a energy efficient building.
Yeah.
I'm just talking about that because I look at the lens of energy renovation, because you can say that your NPC package is a renovation action, so depending on where you start, how much do you expect to gain?
Yeah, these savings, they were like very well evaluated using heating degree days methods and so on. And Yeah, but in this case, there is like no benefit of MPC, for example, on the heat pump efficiency. If we have geothermal buildings, then, for example, as I said, the lower the peak load, the better COP, which would increase the potential of MPC much higher than the 23%. So, yeah, I think there were some simulations and comparison of RBC, or rule-based control, to MPC in the case of geothermal buildings, and the savings are higher than 50%. So, 50, yes. But yeah, you are right that the consumption of these buildings is low. So in the absolute value of the money, it doesn't make sense to look on the building which is, for example, which has power lower than 100 kilowatts, because you save 50% of energy, but on the other hand, it's only, I don't know, 100,000 euros per year, which is low.
But if for the market, and I'm sure some of the big control companies, Schneider Electric, Siemens, Johnson Control, they will implement it. Also because the need for kind of a continuous maintenance of system you can combine with a model predictive control. So I certainly think there is a market for it. I know another company, small company, Italy, ALDREN, they go in the building and promise about 30% saving and better comfort on a traditional building management system. Many of those systems, they are not really operating well. They are installed, but then people forget about them. So they have their own device. They put in and override the building management system. And they have several times proved they can save and improve comfort. So to show it for the customer, they run it 14 days with their system embedded and another 14 days without. So there is a potential.
One final remark to the first question as well. So within to see what can be expected within the project, we are working on a business plan and trade body discussion amongst all partners in the project, and of course there are some MPC partners as well there. So this is something that's under development, and of which there will be more outcome in the coming year. Let's say. I also have a question myself. To the ALDREN project. It was presented that the building passport is something that should be taken with the building through its lifetime. But do you also have an idea on who are the actors that are going to be along this process? Like if you're a building owner, but someone will have to update this to maintain this thing. How have you got an idea on how this would work? Who are the actors and what are the roles that are developed there?
Yeah, for sure. Even when we structure in detail the data model, is because we know that along the path we need different actors. And for sure, even the knowledge of the different actors is not the same. So who will fill in, let's say, the passport and the build log and whatever, should be energy manager or people that will be trained by ALDREN approach, because we need to do that for sure. But at the same time, we were focusing on to have a version, let's say, light of the passport that a final user or owner can bring and understand. That's why we thought about these different actors. So if I reply to your question, definitely is a professional that should fill in the passport.
But the idea is that we need to prepare a training for them, even because already there exists some case of building passport, but they are not all the same. They are focused for residential building, and so even in that case, I think that person that should fill in that needs a training and understand exactly what they refer to and so on. As we said, like which is it this indicator or which energy we should consider and so on. So it's important even the language that will be in to avoid misunderstanding. That's the reason why we strongly believe on the importance of data quality and even who could update. Again, the user can give feedback, for example, but then he shouldn't be the person that updates that. I don't know if Mathieu or somebody else would like to add something.
Yes, thank you for raising the question. This is not an easy question, I guess. Yeah, and maybe the discussion will go on with additional task leaders. But I guess we have to reposition also your question in line with what we do actually with IPCs. Yeah, this passport is not the only item on building documentation, but is supposed to be revised over time and perform, for example, every 10 years, because it has a certain validity. And in line with IPCs, we could figure out that IPCs assessors could be responsible for, at certain frequency, to update the information and building documentation, at least on some topics related to energy ratings. This is quite direct. The inclusion of health and well-being parameters, depending on how far we go, could be also introduced in this vision. The question on addressing or meeting the targets in between predicted and actual performance is maybe to be dealt slightly different. Because this issue is definitely to be considered when we renovate the building. If we just exploit the building without any renovation operation program or planned, maybe the strategy can be slightly different. And some companies do sell services to building managers to actually perform this analysis along the deep renovation process. So depending on the topic, the actor, the stakeholder, or the involved actor may be different, but we are not already to the conclusion on your questions. Would you like to add something, Robert? I feel like you have ideas.
I just wanted to say I was at a very large meeting of financial investors, and they are interested in the building passport, not really for understanding the energy situation in a building, but to understand the investment potential of the property. And if they can get that data in a digital form, they can play all kinds of fancy games financially. And that is why there is a lot of interest in building a passport. Just something for you to think about.
Okay.
Yeah, so just a quick one. So I don't think the current IPC is something they can trust with evaluation.
Okay, I think we will end here. Thank you, everyone, and all the GEOTABS people, it's nice having you here in EDU. And for the ALDREN people, we will continue at 7 o'clock tonight. We started the meeting tonight. Yeah, that's a good, hopefully it will be a good start. Okay, thank you. Thank you. If you would be so kind to take your cups and water and all that and those who have a name tag like this, leave it on the table down there so we can reuse it.